Okay, all right. So thank you very much to everyone present here this morning. Very much welcome to this webinar session. And thank you very much to James as well for joining us today to share his experience with regards to his journey towards digital transformation. So this morning, what I will share with everyone here today would be the operational technologies for a smart factory and generally how we can actually progress further into this space, Industry 4.0 in a very sustainable manner, right? And what are the key concepts of a smart factory that will help many industries to enable them to actually achieve a more sustainable and cost-effective approach towards digital transformation. And this will be what we will share this morning. And we hope to give you a very different perspective into how you can actually integrate these kind of operational technologies very, very quickly in your current manufacturing operations. So these are the areas that we'll cover today. I'll just give a very quick overview on Industry 4.0 and Smart Factory. What is it all about? Then we talk a bit deeper into the operational technologies for Smart Factory. And then we will end the session with a more perspective on a cost-effective and sustainable approach towards achieving these kind of integrations for your current manufacturing operations. So as all of us know that, Industry 4.0 is one of the key buzzwords recently, right? And generally, the key concept or strength of Industry 4.0 is no longer about automation, but it's more about how data is, being the new goal to support people in making the right decisions and hence improving their productivity and efficiency in overall. So generally, Industry 4.0, as we look at it, it's not just a direct plug-and-play kind of solution, but rather it is a journey towards a digital transformation and productivity, as you see the progress from 1, 2, 3, and 4, right? And one key concept about Industry 4.0 is that it doesn't necessarily need to go through a pathway of, you need to go to 2.0, 3.0, then only 4. It can actually skip a step, right? And what matters most is actually about the connectivity of devices and what the data can do for you that will give you a greater value, value creation for your company to make the right decisions and eventually achieve better productivity. So now we talk about the smart factory concept, right? We always hear these 9 pillars or 11 pillars of Industry 4.0. But here in the smart factory here, we talk really about the integration of technologies, because for us, the key importance is actually technology integration, right? How the technology pillars can be integrated to work better for the company, and what kind of technologies will actually create better value for the companies in general to achieve what they want to achieve in terms of productivity. So we talk about the horizontal integration, where we talk about the shop floor integration. You talk about machine-to-machine communication. You talk about, production line to production line communication, and hence, this kind of connectivity will provide you with sufficient information to actually visualize what your production is currently running on a daily basis, right? Then we talk about vertical integration, when all the data is then moved from the shop floor all the way to the cloud, or even to a local cloud, right? You have a public and you have a private cloud, right? And then you talk about AI and analytics eventually to support you in terms of making the right decisions. And then you talk about the digital twin, which is basically a digital replica of your current manufacturing process or production process, which will help you to simulate what will actually happen in due time, right? Based on your current production trend. So today we'll cover more on what we talk about operational technologies, which is one of the 3 key components of a smart factory. You have operational technologies, you have information system technology, and then you have the digital factory. So we go to the OT side first, as the OT portion will be the key importance for many manufacturing industries to start first, and then only you scale up eventually from there. So the key strength about operational technologies and Industry 4.0 is actually about data, right? Well, some people may ask, what can data do for me? I actually receive data from my my supervisors. Every day they update me on what's the current production status. Every day they update me if how many downtime I have, what's the machine issues. But the key strength of it is getting data at the right time, right? So basically, if you look at this chart, right, you talk about the time versus the value of adaptation, right? So assuming that you look at this chart and you think about your machine, right? If your machine breaks down, do you want to know your machine breaks down immediately, or do you want to know half an hour later that your machine has already broken down, right? So basically, if you know it as fast as possible, you can actually make the right analysis as fast as possible, do the right decisions, and then take action, right? So eventually, if all these time delays can be minimized, right, eventually you minimize the entire cost of solving a problem, right? Everything is time dependent, right? And I think in manufacturing industries, generally, right, time is money for you, right? Every minute is every, every dollar that is being created from there, correct? So this is how we can actually use data to actually optimize your cost of manufacturing. So now, what are the kind of operational technologies then that we can talk about in terms of the smart factory? So if you think about the entire automation pyramid, I'm sure that you probably have seen this before. You start at the field level, which is basically your sensors, right? Then you talk about the control level, which is basically your programmable logic controllers and so on. Then you talk about the supervisory level, which is basically your monitoring your system. Then you talk about MES, which is your manufacturing execution systems, and then your ERP, which is your enterprise resource planning systems, right? Now, we look at it as a pyramid, right? Now, the key question is, how are you going to integrate from the bottom level, the base, all the way to the ERP, right? This is actually a key importance for everyone to understand, because most of the time, what I understood from many industries is they start from the top and then they have difficulty to actually connect to the bottom, right? So that is one of the challenges that I see. And most of the time, people start off at the top first. But rather, we should actually look at it from the base level, what you want to achieve, and then slowly move up to the top. And how the interconnection then works is actually through, what are the flexible and modular approach to connect everything together. So we talk about, how the smart factory ecosystem should be modular, right? And flexible enough for industries to actually integrate, right? You talk about Lego, right? You start from Lego pieces, and then you connect them, and then slowly you build them into what we call as a masterpiece. The same thing that it can happen for many, many industries as well. You start with pieces, connect them together, and once you connect all the way to the top, you build your pyramid, and then eventually you have a masterpiece of a smart factory on your own. So the key concept here is modularity as a key factor for sustainable factory concept and setup, right? You want things to be modular, you want things to be connected, and then eventually they can scale up on their own, right? So this is basically how we see technologies can be integrated together. So when we look at the entire smart factory concept, it shouldn't be just, basically it shouldn't be, complicated or complex, right? We need to see it from a step-by-step approach, right? And this is one of the articles that I recently produced together with my collaborators at Monash. Basically, we talk about the step-by-step approach in maturing towards Industry 4.0. So you talk first about data acquisition, then you talk about data processing, and then only you make decisions and take action, right? So this is basically how we see the operational technologies coming into place to help industries move in a step-by-step approach, right? So we talk about the flexible and scalable integration towards a smart factory, right? And this basically, we talk about different machine have different brands, right? And how they are all interconnected together, right? To create a smart factory kind of ecosystem, right? So basically they can connect to each other, right? Regardless of a different brand that you have, right? And eventually what happens is that, you can actually see your dashboard, you can actually have your data storage, you can actually store your data and then give you valuable information. So we talk about a simple illustration of productivity and machine effectiveness, right? Where you talk about, OEE, right? Overall equipment effectiveness. So you talk about the planning, you have a plan, 8 hours, you want to achieve 100%, which is 8,000 pieces per shift, right? Then you talk about availability, right? So that is, how long your production hours are actually, productive. Let's say you only are productive 6 hours out of 8 hours in a day, that is 75% of your total productivity. Then you talk about performance, right? Let's say your machine is targeted to produce 1,000 pieces an hour, but actually you only produce 700 pieces, right? So that talks about your performance. And then you talk about quality, right? Out of 8,000 pieces, or 6,000 pieces that you are able to produce per shift, how many of it is actually defective, right? So although, at every level of A, P, and Q, which is availability, performance, and quality, you achieve 70% and above, right? Overall OEE, you only achieve actually 50% because it is a factor of your availability, performance, and quality. So these metrics actually provides you with the overall idea of how your machines are effective and how they are, how they can scale up from there. So then we talk about the illustration of the 6-week losses in manufacturing, right? We talk about the 6-week losses, which are breakdowns, setup adjustments, idling or minor stoppages, speed, defects in process and rework. Then you talk about the startup losses and so on. So all these things basically produce what we call as your 6-week losses. And all this identification of your 6-week losses can be achieved from understanding your current manufacturing operations, right? And this can be achieved through getting your data, and then you can actually see where are all these losses at actually. And then from there, you can see, from the losses that you have, you can identify what are your unplanned stops, your small stops, your production rejects, and all these can actually be achieved in real time so that you can get the right mitigation steps in place before something bad actually happens. So now, then we think about the overall OEE. How straightforward can it be to actually be able to collect that kind of information from machines? So most of you will probably have machines with tower lights, with emergency stop, stop button. You have sensors that will identify your part in and part out, right? But maybe these machines are at the moment not connected, right? So then we talk about how do we then collect the data to actually visualize this kind of information. So we talk about, availability, performance, and quality, right? So from a machine, how do you identify how to get availability data? So a simple approach would be tower lights, emergency stop, or start or stop button. You can actually tap signals in a machine to give you that information of your downtime. For example, if you have a red light in your machine, basically your machine is down, right? So then you can calculate your downtime. And once you calculate your downtime, you can calculate your overall availability, right? So then you talk about your performance, which means your part in to part out, which is your cycle time, right? Your process cycle time. So you just have to tap signals from input to output, right? How many cycles your machine have run, and what is the time difference between cycles? That is your overall performance. Then you talk about quality. Quality can then be identified through different indicative sensors, right? Or push buttons or switchboards that you can identify, okay, there's a machine failure, there's a product failure or quality issue due to what kind of reasons, right? And all these can actually be captured in real time to provide you the information that you need. And it doesn't matter whether your machine is IoT capable at the moment, because this kind of information can actually be tapped, right? You can actually tap machines regardless of the brand, as long as they have an electrical circuit and you know what kind of signals it produce, give you the right information, and then translate it into visualization dashboards like this, right? So these kind of dashboard systems are there to provide you with the visualization that you need to actually get started, right? So for example, in this kind of dashboard, what I can see from here is if my availability starts to drop to 50% in the first 2 hours of my production, then I know that something is actually very, very wrong, right? It's either operator dependent, or is it machine dependent, or is it the startup time, it's taking too long. Then we are able to identify, right? Then we can take action almost immediately because this is real-time data. Then we talk about performance. Let's say my performance has dropped to 50%, right? Halfway through my production shift. So then I can understand that, okay, my production is having this issue because maybe my conveyor belt has a problem, or maybe my system has a problem, my hydraulic press has a problem, maybe, right? All these things we need to identify through data collection. Then we talk about quality, right? Let's say, for example, operator A, in his shift, his quality is 90%. Operator B, his shift, the quality dropped to 50%, right? So this kind of quality issues can be, operator dependent, right? Or let's say, for example, today you use a raw material from company A, right? And you actually achieve 90% of quality. Tomorrow you use a raw material from company B. Suddenly your quality dropped to 50%. Now that is basically quality dependent on raw materials, right? So these kind of identification steps, can be realized if you actually improve, your data collection steps and automate your whole data automation strategy. Then from collecting a lot of data, from looking at all the kind of data collection steps, you can actually then start to move from, reactive maintenance all the way to predictive maintenance. So being able to forecast when the machine will break down, to identify what are the key factor or steps that you need to take, right? It is as simple as looking at a car, right? You're driving a car every day. Your car will have a mileage counter, right? And you know that every 10,000 kilometers, you need to change your oil, right? That is basically what we call as preventive maintenance, which is a scheduled maintenance, right? Every 10,000 you will change, or every 6 months you will change, right? But do you necessarily need to change your oil every 6 months or every 10,000 kilometers, right? It is heavily dependent on the way that you drive, right? Sometimes you may be stuck in a traffic jam almost every day, and your car is exhausted further, right? Or some people, they travel long distance, so they may not necessarily need to change their oil so fast. So then that looks into predictive maintenance, right? Then only we move on to prescriptive eventually. Now, the whole idea of data is basically helping you to make the decisions early before it actually reaches a functional failure, right? And by having operational technologies in place, you can actually monitor your machine health, over time, right? So that you actually prevent it from further, from only mitigating the steps at functional failure step, but you're actually able to solve, preventively at the early stage, right? Through the predictive maintenance kind of strategy. And these are data-driven strategies to help you make decisions faster, right? And if, let's say by data, right, you can actually understand the machine better and understand the root cause, you make decisions faster, right? Therefore, you up your machine at a faster rate. So this is an example of how, data can be collected, it can be forecasted, and all these are in real time, right? We talk about real time and data collection now because we want to ensure that we can actually, extract that information fast enough to make decisions. So if I can make a decision within the next 5 minutes, as opposed to the next 1 hour, that will actually give me a lot of time savings, right? And eventually help me to be more productive. So then, when you have a lot of data, you can also identify what, is happening in your machine. We talk about anomaly detection, right? So sometimes when your conveyor is actually having a problem, eventually, you can actually predict this faster. Or let's say if you have a certain oil leak, right, in your oil tank or something like that, right, for your hydraulic press machine, you are able to actually understand, what is the level of the oil, when to actually change or top up your oil. So these are what we call as anomaly detection. So the whole key idea about operational technologies is how do you integrate these technologies to give you the data that you need, right? And it's not just any data, it's about the volume of data, how big you want your data to be, velocity, which is your frequency. It cannot be every 1 to 2 days you collect data. It needs to be a certain time scale, right? Depending on your system. Then you talk about variety, right? You don't just collect one signal, you collect many. And then veracity, which is your accuracy of data. Now, accuracy of data is very important because sometimes people say, oh, I have a supervisor that every morning he will collect data from 40 over machines, right? What is the data accuracy of that data collection? Does anyone know, right? If let's say there is some tampering or non-transparency in the data collected, right, we will never know, right? So therefore, automating data collection will create value and hence creating useful data for the management to observe. And hence, by doing all this, you actually reduce your total losses, right? You can move from, your current OEE status to world-class OEE status and maybe even perfect eventually, right? So the whole idea is basically to reduce your overall cost of losses, right? And hence improve your productivity. So these are some of the key advantages of going into operational technologies for your digital transformation, right? You talk about real-time productivity insights, talk about improving machine utilization, more efficient operations, and then optimizing your workforce for improvement. Right? You don't need one supervisor to go one round to actually collect all the information, right, every morning. So you can actually automate the data and you can visualize it from your home, right? Right now, if it's a MCO or CMCO, again, we can visualize it from our home. Your management can actually see the data from anywhere they are. That is the kind of level of transparency that we want to achieve eventually to help many industries move forward too. So the whole idea about understanding, the value creation of digital transformation actually helps to then move many industries to the right direction, and how they can actually move this in a more sustainable approach and more cost-effective approach is looking at building, your transformation roadmap with a more people-focused strategy. Right. So this is an example of a roadmap that we always present to industries. Right. Every digital transformation roadmap starts with the leadership buy-in and commitment first. Right. Then looking at allocation of funding, which looks into talent and building lighthouses in the company. So you don't need to actually do an entire company approach of Industry 4.0. You can start with small projects, right? Get the team involved, get the people involved, build them up to become what we call as ambassadors of the company, right? You would not want to implement technologies and then it become white elephant in the company, right? Where you cannot, where nobody uses, right? You want them to cultivate the culture of, yes, technology is going to help me to get this information and to make me more productive, right? So that's talking about ambassadors. Then you build domain expertise, which is you have your internal team to support you. And having internal team actually helps to improve your overall utilization because you already have an internal team standby to support your entire production system. Then you talk about continuous improvement. And I think most industry will always talk about Kaizen, right? Which you talk about continuous improvement to scale up your operations. So it's not a direct plug and play kind of technology, because eventually the idea is you can continuously improve this to scale up. So how the smart factory ecosystem helps companies to do this? We talk about the multi-vendor approach, meaning to say brand neutral. Any devices should be able to talk to each other in an open communication protocol, regardless of your brand, right? Then we talk about open collaboration concept, which means we talk about open platforms that are already available to help industries to integrate, right? Every integration development of software hardware integration is currently available for people to explore, and they can integrate on their own. This is actually a possibility, right? Rapid prototyping and development. Basically, if you don't need like 6 months to develop something, to develop a kind of integration, it can be brought down to maybe a month that you can actually learn how to do it, and you can actually prototype and build one set for your company. The whole idea is reducing your time to deploy. So it's always reduction of time. Because eventually how we see is technology should be modular, compatible, flexible, and scalable, right? So this is basically helping many industries to reduce the complexity and reduce your entire cost of integration. So that's how we see that kind of technology to be integrated. So we break it down even further to 5 levels of maturity for industries, right? We talk about level 1 to level 5. Because many industries always, when we talk to them, when we do factory visits, when we explore and scope their current manufacturing operations, we actually ask them, okay, what is your final goal, right? Most of them will say that, okay, I want AI and analytics in my company, but generally the first question to ask is, where's your data collected, right? So then we bring them back to level 1, collection of data. First, visualize your data, then store your data, and then formulate, and then do analytics. Without data and without historian data trends, there is really not much analytics that you can do, right? It's actually very, very complex, because how machines learn or how analytics learn is through data. Basically, we learn through experience, they learn through data. So these are basically how analytics strategies are being put in place. So whatever dashboard that I showed you just now, right? You can actually scale up further, right? You can actually build your own cost-effective and sustainable platforms like this, monitoring not a single machine but multiple machines. It is up to you, right? Basically the whole idea of integration is how do we connect them together in a more cost-effective and flexible manner, right? So you can actually monitor your entire operations, and once you are actually ready, you can scale up. You can look at different kind of parameters. You want to look at power, you want to look at temperature, humidity, is your choice, right? Eventually, what we provide to support industries is the competencies required to develop these kind of technologies. And then you can learn, you can actually build it on your own, and you can scale up. So this is how we show a simple topology from level 1 to level 5, right? you don't necessarily need to go cloud, right? Cloud is basically, of course, a good feature for those who do not have their internal server, right? But if you have your own private server, you have your own private cloud, then start from your private cloud integration. You start from level 1, which is data collection. And if you notice here that we have two types of methods of collection of data. One is we call it IoT gateway. Second is we call it data generation. Why data generation is more popular? Because many machines now, they don't have access to their PLC codes. They don't have access to the access to modify anything in their current controllers. Therefore, data generation is a program where you can tap signals from machine and get the information that you want through a non-PLC based method, right? Then you talk about, after you collect data, you talk about visualizing and storing, right? So that's level 2 and level 3. Then you talk about building your own OEE, that's level 4. Then only you move up to analytics. So all these are actually capable to be taught, and we can actually teach you exactly how to do this kind of integration through our programs that you can see here. So we have all the way from level 0.5, which is actually, this OT topic is actually part of the level 0.5, which is scaled down for this webinar, right? But we go deeper into the technical overview, in this program. Then we talk about level 1, level 2, level 3, level 4, level 5 in different programs that we have. So all these are actually available for any participants who wants to start their transformation journey. We can actually help you from here. So why the concept of a smart factory that we introduced to industry is sustainable and cost effective? Because it helps to create maximum value creation through what we call as a digital transformation ownership. Basically, you own the technology. Sustainable technology integration. Basically, you can scale up at any time because the platforms are open and scalable. Lower upfront investment, hence reducing your cost and improve your overall ROI. And one of the key concepts of learning and doing it on your own is basically the readiness for it to replicate. So you start from one machine, eventually you can scale up to multiple machines. So this is actually one of the kickstart success story that we have from training to implementation that we actually did with a number of industries. And we have James here, who is actually one of our key success story as well, where he will share more deeply what he has done later. For us, what we share with you today is the framework, right? So the idea is, you have a technical team, then you go through a talent development program, you identify a project, start from one project. Once you finish, then you scale up, right? So we always start from what we call as lighthouses, right? So then eventually you can slowly scale up from there, and then you can integrate the technologies once you understand fully how it is done, right? It's all about then replication after that. So why we go with this method? Because we think about the people-focused strategy. Because eventually, at the end of the day, the real domain experts are you, right? You are the domain experts in your industry, and what we are equipping you is the tools and the competencies to help you to scale up further. Because eventually, having technology ownership will be more sustainable for many companies, and we are all ready to support you towards that direction. So this is generally what we do in the Malaysian Smart Factory. Just to give a very brief overview, we do tech talent development as a core. We have the Smart Factory, which is actually a technology learning platform. We run a proof of concept and lighthouse projects. Basically, we understand industry problems, and we will try to develop a solution behind it, and then we will teach you how to do it. So that's generally our key concept and uniqueness of the Smart Factory. We have a model factory that you can now visit as well. You just have to let us know if you intend to drop by. And now we actually run programs digitally. At the comfort of your office or your home, you can actually log into our hardware, and you can actually do the integration at your office site as well. So this actually helps to enhance the training experience while ensuring the comfort and safety of our customers and participants. So if you have completed, your RA, readiness assessment, or you have completed this productivity 1010 assessment, these are the services that we can offer to participants who intend to join our programs, or our companies who just want to understand where they are at. So we can actually look through your documentations, do an initial scoping, and then we can understand what are the technologies that you need, and then we can recommend the right programs for you. So these are the additional services that we can do for companies who are keen. And of course, if let's say you would like to understand what else that we do in terms of SHRDC, you can follow us on our links over here. We have extensive library of YouTube webinars now that you can actually go into to learn and to understand what are the key technologies that we have done in terms of webinars, so that this becomes a resource for you to understand the technologies better. And with that, that's all I have for this morning. Thank you.